Hey guys, welcome to the Tech Career Booster. Today I want to start a new series of videos talking about the reflections on the career of a programmer, of a software developer. The idea here is to be discussing what's going to be the challenges and what the devs are going to be struggling with. So I want to bring to you guys a little bit of what's the most difficult things you're going to be finding on the career, on how you can actually uh, go through it and take that correctly. So my name is Joss Balardin, and in today's video, the first of the series, I want to be talking about problem solving. So I want you guys to think of how to think like a programmer, how to structure your thoughts and master that essential skill of problem solving. And to start that, I want to start with talking about what's not problem solving. Problem solving is not about memorizing solution. It's not about keeping everything on your mind and trying to memorize thing. It's about to actually break down complex issues into smaller parts. So what it's not copying code from the internet. It's not copying things and try to make that work. When you try and fail, that's not problem solving at all. But if it's not problem solving, what actually problem solving is, as I just mentioned, problem solving is the way you break down a complex issue, something hard to tackle. You break that down into smaller and manageable parts. So you have to understand what's the root of the problem and find efficient ways to actually tackle it. You're going to have to develop a mindset that allows you to approach challenges logically and systematically. And why do you have to learn that skill? Why problem solving is important? Why solving those silly problems, like when you are starting to learn how to code? Why do you have to learn like Fibonacci or factorial problems? And why do you have to learn those silly things? Because that's going to be the difference between a good dev and a bad dev. Like when you learn just the language, you know the commands, but you don't know how to structure them. You don't know how to put them together to actually create a nice piece of code. When you learn how to solve the problem, then you become a good dev, because then you become how to structure things and not only put a few commands one after other without knowing if that's going to work or not, or if that's going to solve your problem or not. And also, the dev tests, they are all based on problem solving. So if you're going to do a dev test, like if you're going to find a position and someone want to hire you, you're going to be doing tests. They always do technical tests, and all the technical tests, they are based on problem solving. So your capacity of solving problems is going to tell how good you are as a dev. That's the main thing. Talking about problem solving reminds me about one guy which I hired once. The year was 2005, and that's gonna tell you guys how old I am. At that time, I was managing a dev team for a web company. So we used to build websites and web systems. And because we were living in a small city and we didn't have many professionals available at that time, our decision as a company was to actually hire people who were starting to learn. So whoever was starting the uni or was starting a course, a TAFE course or something like that, we were hiring them and we were actually teaching them at the company as soon as they start. And then we hired a guy called Giovanni, and that guy, that was remarkable to me because even after like a month or something, he was working with us, he was learning coding, he was doing like small stuff and things in our code. And he came to me and said, "Oh, I'm having a problem here. I actually don't know how to solve this thing. I have to make this list. And to create this list in the screen, I'm not sure if I should use a while or a if statement." And then I look at him, and in my mind was like, man, this guy is not going to become a dev because he doesn't know the difference between a while and an if. One is a loop, the other one is a conditional statement. So it's not even for the same purpose. If his question was about a while or a for, or some loop commands, that should be right. But a difference between a loop and a conditional statement, that was too much to me. And then at that time, I doubt like he would be able to learn coding, or he would be able to become a good dev. Um, but that was actually a lesson to me. I've learned that people can learn. I've learned that people can become good devs, because obviously I've tried to help at the time. I helped him how to solve that problem, and I explained to him how to break that down in small pieces and go step by step and actually resolve his problem using the commands he had on hand. And after that, Giovanni, he started like to flourish. He started to understand better the problems and to see better the things. And like, even after almost 18 years now, it's been a while since last time I catch up with him, but I know he actually got big jobs and big companies in Brazil. He was working for a broadcaster, like similar to 7 Network or 10 Network in Australia, but that was a big network in Brazil. He was working for those guys and building their portals and things. So he actually succeeded in his career, but at the beginning, I doubt him. And I would say the key thing I helped him at that time was with problem solving. He was struggling with that, and he was uh, having difficulties to actually getting somewhere. And after learning problem solving, that's what like unblocked him to actually continue with his careers. And then you probably should be thinking, okay, but I'm just a beginner. Now it's 2023, it's not 2005 anymore. Shouldn't I focus on learning languages first? Why I should focus on problem solving if I still don't know any language, or if I'm still starting as a dev? And I would say it's crucial to learn a language, but also problem solving is as important as the language. If you only know a programming language and you don't know how to solve the problems, you don't know what to do with those commands. You don't know what to do with those things you just learned about the programming language. And also, problem solving is a universal thing. It's going to be applied to any language and to any framework. The way you're going to have to solve the problems is always the same. The way you structure your thoughts is always the same. And then you just put in that in the commands. That's why it becomes so easy to change languages over your career, because all the languages, they work in similar structures. So once you learn one language, and once you learn how to solve problems with your programming language, if you have to change the language, it's a way easier, because you already know how to solve the problems. So I would say problem solving is the most important skill you should have as a dev. And then you probably can come back to me and say, but I can always look up the solutions online. I can go to Google, I can go to GPT, and I can get the answer. Why I should be learning that? I would say, yeah, you can go to Google or GPT or Bard or whatever and grab the solution from there. But how do you know that's the correct solution? How do you test all the scenarios in that if you don't know how to solve the problem? You are the one who is the expert, not the online stuff. The online tools, they can help you. GPT, Bard, Google, whatever, they can help you to actually resolve your problem, but they are not going to resolve the problem to you. If you don't understand how to structure things, how to put things together and actually get the solution, nothing is going to be able to help you. Obviously, if you get like some small problems, like I was mentioned, Fibonacci or factorial or that stuff, obviously Bard's going to give you the solution. But how do you know that's the correct solution? How do you know GPT is telling you the truth? You know it can be wrong. And if you can't check it, you know, you can also come back to me and say, but isn't problem solving something you were born with? I'm not sure I can learn it. Like some people, they have like an easy way to approach that, and for me it's so hard. Yeah, it's true. For some people, it's harder than to other, but like any other skill, problem solving can be learned. You can improve that if you practice and if you have consistency, if you look at problems, if you look at real things, and if you do all the exercise proposed when you are learning programming. That's the way you're going to learn problem solving. Don't give up. And that's the point where many people they start to struggle, and then they think, oh, that method is not good. I was learning through YouTube, and then that video gave me a challenge and I couldn't go through that, and so that video is not good. That YouTube teacher is not good. Or I was in a school and that the teacher in the school gave me these problems, and then it's being too hard to resolve that, and then that's the teacher's fault. That's usually the approach people take. They usually blame someone else when they struggle with resolving the problems, when you really should look at yourself and see, okay, am I doing the right thing? Am I practicing enough? Am I trying hard enough? You should be trying hard enough to actually solve that and to actually get to where you want to get to. Okay, so you probably should be now asking, okay, but how can I learn that? How can I actually approach the problem solving? I don't know where to start from. And I can start answering that, telling you how to not approach that. How is the wrong thing to actually do that? And but that's the way most people start doing. And the common mistake is actually jumping straight into the coding without understanding the problem. Most people, they actually, when they have something to solve and when they face a challenge or when they get an exercise or something, they open their IDE, their editor, and they start to type, I'm going to code that. And you start to just try to code without really understanding the problem. And more important, how you're going to solve the problem. If you didn't understand the solution, it's going to be very hard to you to code that. That's often is going to lead you to more issues and wasted time than actually fixing or resolving the challenge or delivering the solution. So if coding straight away is not the correct way, what is the right way to do? What's the correct approach? The right way is actually to first understand the problem thoroughly. You should be diving deep into the problem and understanding what the problem is. Once you understand what the problem is, you can break it down. You can break it down in smaller pieces. You can break it down in smaller problems, and then you can plan your solution based on those smaller problems. You can plan your solution by solving the problems one by one. And then once you have solved all of them, once you know how to solve all of them in your mind, then is the moment when you actually start coding. Then is when you actually start writing down things. It's like building a house without a blueprint. Would you start a house without a blueprint? If you don't have a blueprint, how do you know what to do in the house? It's the same with any code. Whatever you're going to write, whatever solution you're going to do, you have to understand what you're doing in your mind first. If you don't imagine, if you don't use imagination to actually build the solution, build step-by-step approach, how you're going to solve that, you're not going to be able to solve it. And once you have that, then you're going to be coding and try to go. So I'm going to give you a quick step-by-step on how you can do that. So the step-by-step to actually solve the problem, to actually tackle something hard, is understanding the problem first. That's the first thing you should do. Before anything else, you should make sure you know what is the outcome expected. What's going to be the solution expected for that problem? You know what the problem is. Once you have 100% sure what the problem is, then you break it down. You divide that into smaller problems, more manageable parts. So when you split that in more manageable parts, like smaller parts, it's easier to actually find a solution for that. When you have a big problem, you don't know exactly what to do. But when you split that, this is a small problem, and that's another small problem, and that's another small problem, then you go tackling one by one, And once you put everything together, you have the solution for the bigger problem. So first step, understand the problem. Second step, break it down. You're going to break it down in smaller pieces. And then it's going to come to the third step. What's the third step to actually solve a problem? Before diving into coding, plan your solution. That's the third step. You should be planning how you're going to tackle each of those small problems. Once you know that, then you can start coding. So third step, plan your solution. You can create pseudocode, flowcharts, any ways to actually plan that. You do that on paper if it's easy. When I was learning, I used to do that on paper. I put a piece of paper in front of me and start to write down what was the problem, what would be my solution, break that down in variables, in steps, in loops, all in the paper in front of me. So it was more visual to me. And most of people, they are different. You can be doing on paper, you can be doing the computer, you can be doing your mind, you can be doing a flow chart, whatever is easy to you, but something you can actually see the solution before start coding that. And then it's going to come to the last step, which is coding. That's the last step. Once you figure out what the solution is, then you're going to be coding. Then you're going to be putting your hands down and start writing your code. And most of people think coding is the end of the process, but we still have another 2 steps to go through. I just said that was the last step, but that's the last step for most people. They think it's the last step. I wrote the code, it's done, gone. It's not. You still have to test your solution in the code. So you should be doing like table tests. It means like go through your code line by line and doing exactly what that line says, like on paper, and then you're going to make sure your solution is working for a few situations. You can bring some situations as an example, as a data entrance, so you can enter some data to your code and run that and see what's the behavior, and see if it's giving you the expected answer. And then the last step, the real last step, which most people don't do, and that's what makes the difference between a good dev and a bad dev, is actually refining the solution. So once you finish that, you can go back to your code and refine your solution and look at that and see, is there any way I can optimize that? Is there any way I can enhance that? I can improve that solution? Can I make that quicker? Can I make that faster? Can I make that more understandable for other people who's going to read my code? So those sorts of things you should be checking in your code when you finish that. So that's the step by step to actually tackling that problem solving stuff. You're going to understand the problem. Once you understand the problem, you're going to break that down into smaller pieces. Then you're going to plan your solution. Once you plan your solution, you're going to start coding. Once you have the code done, you're going to test your code. And after testing your code, you're going to refine that. You're going to review and check if there's any way to improve that. Those are the steps to actually tackle problem solving stuff. Those are the steps to actually create any feature or any enhancements you want in any piece of software, or even to start a piece of software. If you don't have that, don't even start. You can't create even an exercise. You can't do an exercise without understanding those things. So you have to remember, thinking like a programmer is a journey, not a destination. Like if you remember that, you're going to have the correct journey, and you're going to be practicing and practicing and practicing. And then at some point, you're going to become a really good dev. So you have to be persistent. So with practice and persistence, you find that problems become challenges, and challenges become opportunities. So don't leave that for later. Start doing that now. Start trying to solve problems now. And even if you are just starting a language, you should be doing that in parallel. That's even more important than learning a programming language. And that was all I had to you guys today. If you found this video helpful, don't forget to like, share, and subscribe. And until next time, keep coding and keep growing.